Hi, here's David from Glaswerk, and today I'm talking with one of our optical designers, Christoph Horneber, who was
Hello.
working for the last several years on our anamorphic lenses. And let's start right away. Christoph, maybe you can tell us a little bit about yourself and how you became interested in optics.
Optics is part of my life since I was a student or even before. So I had a photographic camera for many decades, I have to say right now. At university, I specialized in optical metrology. And afterwards, I went to Leica Camera, where I became optical designer. There, I learned how to design lenses and so on. So, one of the lenses, or two of the lenses, which are still sold today from Leica, is the Noctilux 50 millimeter lens and the wide angle 3LMA lens. These are designs which I was happy to make, which was a real challenge at that time. And after Leica, I went to Switzerland to a company called Space, which basically does everything you can build for satellites. And there I was managing director for the optical development. So we built interfaces for optical laser communications and telescopes, stuff like that. After that, I went to a small company called Hembach Photonic in Germany, close to where I come from. So back to the roots, an engineering office, engineering bureau, where we made everything from automotive through space and several imaging optics until finally David came along and asked the question, hey guys, would you like to do something for us? We've got here an idea. I just want to have a 3 lens element design, very simple. And that's where we came in contact.
So you developed all kinds from photo lenses to special optics. Maybe one lens that you mentioned that was is very well known, the Noctilux. What was so special about that lens that you made for Leica?
Well, the Noctilux design is quite old right now from today's on, but
Mm.
at that time, 12 years ago, when I started with that lens, it was the fastest lens in the world. So there was no lens for a viewfinder camera faster than 1.0 aperture. So the Noctilux is a 0.95 aperture. And the CEO, the Leica CEO at that time, told me, don't care about money. We just want to have the best lens in the world, and that's really nice. At that time, the challenges were the restricted volume because it's a lens designed for the Leica M camera. The lens must be somehow small. It's not really small, but it must not be too large because it would block the viewfinder. And so that was the main restriction, really the available volume of the lens.
Wow. Christoph, which focal lengths did you design for Glaswerk? And what focal lengths are you currently working on? And maybe compared to the other lenses and projects that you worked on, what was the most interesting thing about designing anamorphics? And maybe also what were the challenges?
The main challenges are really that we give up the rotational symmetry of the lenses with anamorphic lenses. Anamorphic lenses contain not only spherical and aspherical surfaces, but also cylindrical surfaces. And this makes it really complex and difficult for design. In the past, we started with a 50 millimeter lens, and then we followed with a 75 millimeter lens and the 60 millimeter lens, which are all finished now. And currently, I'm working on the 180 millimeter lens, which is again challenging because it's a very fast lens compared to the long focal length, and we have a lot of uh, constraints, or a lot of constraints from our customers, from David and Viola, that makes it not really easy for us to design these lenses. So the main challenges really are the bokeh, such that we don't cut off the bokeh, but you really see this nice oval shaped bokeh from the center to the edges. It's never cut off at no distance. And this is one of the challenges. And the other two really challenges are that we call that in German Mumps and Pumpen. Actually, I don't know really the English name for that. Maybe David, you can support me
I
in
think
the correct
mumps
wording.
it's the same. And
Mumps is the
breathing,
same. Breathing and
pumping,
breathing. Yeah.
breathing.
Okay. So there we have really just a few percent
Mm.
of tolerance between the different between the different focuses, and that restricts the degree of freedom we have for the optical design. And it also, in the end, makes it necessary that we use a lot of single lens elements. So this is also the reason why we have a lot of lenses in there. But the look is really nice, I have to say. So the feedback we have from first beta testers is really positive. So they see that a lot of work went into that design. And yeah, I'm happy that we were able finally really to meet all the requirements which are necessary to have
Mm.
an excellent lens.
And so, just based on the design and the process of the design, was there something very interesting or new for you? And also, were you kind of surprised by some of our requests?
For me, new really was mumps,
Mm.
obviously, because this is a effect that only takes place in anamorphic lenses. You don't have that in
Mm.
normal photographic lenses, so we have to learn how to compensate for that, really. This was a challenge. The other requirements are simply tough, but not really new.
Mm.
But as I said, they contribute to the fact that we have complex lenses.
Mm.
But yeah, it was a lot of work to design that. I have to say, in the end, we are talking about lenses depending on the focal range, which are between 15 and 20, or which contain between 15 and 20 lens elements. And this is really a lot, even for photographic lenses or for Cine lenses, because you stack all the tolerances one after the other for every single lens element. So you have to work really high precise with a lot of knowledge, and everybody needs to know what he or she is doing. But yeah, that's a nice challenge, because this is the opposite of easy, and that's what I like.
So I remember the first time that I talked to you and your colleague about flares, um, and like this kind of special design approach that we had. Um, was that surprising?
Absolutely. So now, as you say that, I
Mm.
remember quite a few discussions which were really surprising to me. So compared to photographic lenses, the absolute high-end performance sometimes is not even wanted. So you don't want to have like 160 line pairs with 50% of contrast, but you want to have a nice smooth look and a harmonic look. And for example, when David told me that people put something at the back, like some sort of, I don't know, grease or whatever, to make a
Net
soft,
filters.
yeah,
Yeah.
whatever. I was really shocked when that when I heard that for the first time, because photographic people never would do that, or rarely would do that. And also about the flares. So normally you try to avoid any flares at all. You want to have a complete, clean, neutral look without any blue or green or whatever flares, and or ghosts. And when I heard that you want to have sometimes this solid horizontal blue flare, I was surprised, and from that time onwards, I could never watch a movie without looking at these flares, and I was really surprised seeing that this is used in many films and many movies, and that it's something in your brain that people really associate with that flare, some sort of look and so on. And yeah, we had to take care during the design that in the end we are able to implement the flare if the customer wants to have that, or if he wants to have a clean look, have it without the flare. That was really something we had to learn to take care about a artificial way of dropping the performance of the lens.
Well, thank you so much for your time. It was great to talk to you.
You're welcome.
Um, I'm looking forward to the next interview that we're going to do, hopefully with the finished lenses in our hands and also with a 180 design. So again,
Yeah,
thanks and talk to you soon.
talk to you soon. Okay,
Bye.
bye-bye.